Alright everybody, welcome to this explanation of the data parallel algorithm for the n-body simulation. Now remember, what we want to find is we want to find out how each of these particles in red map to any of these 16 grid cells. And we do this mapping based on the particle's position, that is the x and the y, and to seeing how it matches with the position within the cell of this 16 cell grid. Now, we looked at many algorithms during the lecture, and we also looked at this one, which is data parallel, and it will reduce contention within the data structure, but at the cost, of course, of doing many passes towards the data. So our first thing is to do a parallel swipe across all the particles and map the particles to the grid. So what I'm going to do with red here, I'm going to look at all the particles IDs. Now I have 6 particle ID. I have 6 particles, 0, 1, 2, 3, 4, and 5. And what I'm going to do now is I'm going to see with my grid ID, I'm going to see, of course, please, grid ID, I'm going to see where these match. 0 matches on 9, 1 matches in cell 6, 2 matches also in cell 6, 3 matches in cell 4, 4 matches in cell 6, and 5 also matches in cell 4. So what I've done this algorithm parallel across particles, and this should give me a lot of parallel sets. In step 2, I'm going to sort this grid ID array, and once I do the sorting, I will also swap between the particle indexes. So basically just keeping these pairs together. So if I sort this, I'm going to have on the grid array, I'm going to have 4, 4, 6, 6, 6, and 9, which corresponds in terms of the particle IDs to 3, 5, 1, 2, 4, and 0. Okay, so now what we have is we have a sorted grid array, grid index array if you want, grid index array, grid ID array, and a particle ID array, which is this one. And what we want is we want to get from this data structure to this data structure in the minimum steps possible, ideally with the least contention. So what we're going to do is we're going to do a parallel algorithm over each of these elements, and I'll provide the code for the algorithm on the forums, but basically what you're looking at in step 3 is you're looking at obtaining 2 arrays. One is called cell start and the other one is called cell end, and these arrays will be indexed based on the grid array. So they'll be indexed, we're going to have 0, 1, 2, 3, 4, 5, and so on. And the start and the end here will be these positions in the particle index array. So here, for example, the start will be 0 and the end will be 2. Because what we're looking at is we're looking at obtaining all the particles from 0 to 2, excluding the 2, so basically just 0 and 1. The code on the forums will provide an explanation for this as well. Alright, I hope this clears things up.